time for sure. So
Okay, sounds
Okay.
good.
yep.
Someone's super loud. I don't know what. Well, a little bit of feedback coming out. Okay. I will read. I can start reading with question 3 if you want.
Sounds good to me.
Okay. So in a pie chart, why are the slices or sectors different sizes? So I don't know if you want me to read the options, but the slice of each slice is random. Each
Probably
slice. Okay, so the slice of each slice is random. The slice of each slice is determined by the number of categories. Each slice represents a category, and the area of each slice represents a portion of the total occupied by the category. That one
Probably
sounds
number
right.
3.
Yeah, okay. You agree, Angie? Does that sound good?
Yeah, the third.
Yeah, the third.
Mm-hmm.
Okay.
I'll read the next one.
Okay.
How are bar charts and Pareto charts related? Pareto charts are constructed from tossing a coin several times. They are identical. The only difference between a bar chart and a Pareto chart is that the bars in a Pareto chart are ordered largest to smallest, going from left to right.
That one.
Yep.
I would say that.
Perfect. Angie, do you want to read the next one?
Sure. We conclude that, I don't know what it's called, P is normally distributed if n times P is greater than or equal to 10 and n times 1 minus P is greater than or equal to 10. Is P the true proportion or the sample proportion? And I said true.
Sounds good. You're excited. Yeah, that's right. Yeah, I think it's true too.
I think it's true, yeah, true
Okay.
proportion.
Okay, so what is N? Sorry, my screen flipped. Okay, what is N? The number of successes, the number of candidates in an election, or the sample size? The number of the sample size?
Isn't it the sample size?
Yeah, okay. So I thought.
If P equals 1/4, what is the smallest n that satisfies the requirement?
Is there a certain number for this one, I feel like?
Yeah, you have to use the equations from before.
Okay, sounds good. All right, we'll get on that.
Would it be 40?
Hold on, sorry, I'm just finishing mine up. Or trying. What is this one? Is that when you did like the z-score divided by p?
No, it's the ones they have listed up at the information section.
Oh.
So I think it would be 40.
Oh, yeah, okay. I was in the wrong section. Okay, I see it now, 40.
Okay.
I can't remember if is it my turn?
I think it's Angie's turn.
Oh, okay, sounds good.
Okay, so suppose n equals 24 and p equals 0.4. What is the mean of p?
Isn't that just 0.4?
Approximately. That's what I was thinking since there's not any.
Isn't
information.
P different than hat P?
Oh, is that a hat P? Does-
Oh,
I don't know what it's called, but they look different.
No, I guess it makes, okay. Hat P. Adam,
That's
what do you
it's
call a hat P? How do you pronounce, what do you call that?
It'd be P hat.
So what I-
That's really all it would be.
That is funny, okay.
So to find that, do we do
Well, P
X
hat's the
over
mean,
N?
right?
Are you asking me, or
Sure.
are you still
That
trying
was
to
just
figure
a
it
group,
out?
but sure.
You're part of the group today.
So if you go to in the textbook, it's in section 3.2.2, the mean and standard deviation. It gives a really simple formula. It it just says the mean of p hat equals p.
Equals P.
Yeah.
But I saw
so,
that, and then there was somewhere else where it says, okay, if you go down just a little bit further in the worked example 3.3.1, it says P hat equals X over N. Okay, sometimes that's not the same.
Well, so that is what p hat is, but p, you got to remember that p hat is it a distribution? It's been a while since I've done sample proportion. P hat is normally, well, it is, yeah, then it would have to be a distribution. So when it what it's asking for here is not p hat by itself. We're asking for the mean of p hat.
Okay.
So P hat is P, which is the mean, right? Is that what we came to the conclusion of?
The mean, I think if I heard you right, I think it's the other way around. So P is the mean of p hat.
Oh, P is the mean of P hat, okay.
Yeah.
Okay.
So for the answer to question 8, it's just 0.4.
0.4.
Oh yeah, the mean of P
because
hat
that's what
equals
P
P.
is.
Okay.
Okay.
Whew.
Well, cool.
Moving on.
Okay, what is the standard deviation of P hat?
Oops.
Oh, so that is,
More
the,
equation.
yeah, lovely.
Good thing I like math.
So then that's just 0.1 when doing that
0.1?
equation. That's what I got.
Yeah, that's what I got.
Still working on it.
Keep working, you're good.
Okay.
What did you get?
0.1,
Wait, what? Yep, that's
0.1?
what I got too.
okay.
Oh, I can read the next one.
Okay.
Brittany's batting average is 0.3. We want to determine the probability she will get more than 35 hits in her next 100 bats.
Okay, so on this one, if it's saying what is p hat, then it's the x over n,
Yeah, I think this is when it's x over n, because we have,
because it's not the mean. Okay, I just needed to clarify that.
that makes sense now. Okay, yeah, that was a good. So x over n.
So that would be like
what
35
would be
divided by
X?
100.
So that would be 0.3. Wait, what?
Because isn't X,
No, wait.
as far as I understood it, is like when they were doing the flipping of the coins, how many heads you got, that was X. So wouldn't it be the 35?
This would
35
be 0.35,
Yeah,
right?
that's
you
what
divide
I'm
it by-
thinking. Uh-huh.
Oh, because you do the 35 hits divided by the 100 at
And then like
bats.
100 bats.
Oh, I'm like, what is that? What are you thinking, Angie?
Yeah, that's what I wasn't sure of, if it was the 35 hits or if it was based on her batting average. I'm sorry, I'm on a military base and I have to salute the flag. Sorry.
Oh yeah, you go salute.
It's 5:30 p.m. and they're playing the anthem. But I'm gonna listen to you.
So, okay, so batting average. So it's x over n, which would be n is the 100.
Mm-hmm. Because in one of the earlier examples they gave, they didn't have X being the point, whatever, they didn't have it being the proportion.
Yeah, so I think it is 35 divided by 100.
Mm-hmm.
Would you concur, Adam?
I would concur.
Perfect.
Okay.
Good.
Which
So
one
it's
would
based
be
on
which?
the 35 hits? I'm sorry.
Yeah, so you take the 35 hits, divide it by 100, which is the number,
100? Okay,
and then that would be 0.35.
5. Okay, got it. Thank you. We're almost done.
Yeah, you just keep doing it. You're fine. All right.
Okay.
So for the whole song, do you just stand up there and salute the flag? Can't speak. Thought I didn't hear me. Whatever. I'll just keep doing what I'm doing. Okay. Did you get 0.049? Wait.
0.049.
Yeah. Did I get that wrong?
Let me redo my
is-
calculations to double check.
Like,
Huh.
diluted the flag.
Okay.
Sorry, real quick. You're doing the standard deviation of p hat right now, right?
Yep.
Yes. Oh,
Okay.
sorry. Number 11. What is the standard deviation of P? Let me.
I'm sorry, I lost sound for a minute. Are we still on 11?
Yeah. What is the standard deviation of P? Or
P hat.
yeah,
Okay.
P hat. P hat.
P hat. Standard deviation.
Yeah, don't.
P hat. Okay.
Okay. 0.4. I don't know. Do we have to do anything with the average in that one?
P hat.
Isn't the average P? So we
Oh,
would be
P's
using that.
0.3. Hold on, I did the wrong number. 0.046 is what I got. I put 0.4.
Yep, that's what I got.
Okay, sorry. I made a mistake on my calculations.
0.046.
Yeah. So using P as 0.3, P has 0.35, and the number is 100.
Okay.
All right, whose turn is it to read the next one?
Oh. What is the z-score?
Yeah, so number 12, what is the z-score?
Okay.
I'm getting 1.087.
I'm getting 1.091. Let me double check my calculation, make sure I did it right.
Okay.
So you did, the P has 0.35,
Mhm.
P has 0.3,
Mm-hmm.
and the standard deviation has 0.046, and you got,
1.087.
I'm getting 1.091.
Did you use your parentheses?
Yeah, I did mine in Excel, yeah.
Okay.
What are you getting, Andrew? Did you get it yet?
0.234.
Hmm.
Was
We
that
are
a
all
number
over the
that
place.
either of you said?
Mm-mm.
Well, don't trust mine. I'm not
You might have not, did you do your
trying to do
parentheses?
this with. I thought so, but I'm not sure. Let me double check it.
Sorry, one more time. What were the answers that you guys got?
I got 1.091,
I got 1.087.
and Angie, I don't know what she got. I can't remember, like 2.285,
0.234.
0.234, so.
Okay.
Are at least one of us right?
Yes, and actually, I think what happened is one of you rounded and the other did not.
Oh,
So you're both.
I rounded.
Rounded to, what did you?
I
What did you
rounded
get again?
1.091.
I got 1.086. 087.
1.087. So if you round it up, you get 1 point. See, but I put out my decimals and I still got, it's like, if I pull them out, it's like 1.09109. I don't know.
That's weird.
That is weird. C hat, okay, or P hat, 0.35 minus
Yes.
0.3 divided by
Okay.
0.046.
So I figured out what's going on. So if you use Excel and you
Mhm.
use the what Excel outputs when you do the first what is it?
Oh,
Hold on.
because I'm the standard deviation, because I'm just like, it goes down. Like I've made it so that I have the like standard deviation of P hat, and then it will automatically put in like the
So-
P hat and the standard deviation. But
So what I did, I went back and I looked through my history and I put in 0.04582. So I like did the rest of the numbers and I got the same answer as you. But if I just put in 0.046, then I'll get that other answer.
oh, okay, that makes sense. Because it's doing it without rounding. Is that what you're talking about, Adam?
Yeah. So I'm just double checking here. So the answer that they're looking for is the one that is not rounding. So you want to not do any rounding till the very end. So if you don't do any rounding, then you end up with the 1.091.
Uh-huh.
Okay.
So Excel is fine, like if you just plug it in, like I've been doing, putting it in, like
Yeah.
it doesn't round it kind of until the end. Okay.
Yeah,
Makes
I
sense.
did it. I did it in Excel too, and I got the 1.091. So
Okay.
So Angie, were you,
Okay. Yeah, I've been
figure it out?
figuring it and trying to ignoring what you were saying. So I ended up with 1.091.
There
Perfect.
we go. Yay. Good.
It is right. Yay.
Yeah.
Okay.
All right. Who wants to read 13? Whose turn is it?
I'll read it. What is the probability Brittany gets at least 35 hits in her next 100 at-bats? So that's 1.091. That's 0.8624.
What equation did you just do?
I just used the normality graph
then-
thingy.
Okay. Let me see. Let me plug it into.
I'm lost on that one. Will you show me?
It's just basically we just calculated the z-score. You just use the z-score to see getting at least to that number.
Okay.
So all shaded on the left side.
I got point, no, it's shaded on the right side, right?
But
It's
isn't
point-
it the probability that Brittany gets at least 35 hits?
So then it would be a, wait, isn't it 1.138? Hold on a second. Let me read the question again. At least 100 bats, so then that would be, you would shade above it, right? I don't know.
Wouldn't it be shaded to the right if it were higher than 35 hits? And then to the left if it were less than or at least 35 hits?
I would think so because her average was 30.
I think it's shaded to the right, at least 35 hits. Because then it's at least, hold on, let me look at this question again. What is the probability Brittany gets at least 35 hits in the next? So the z-score, so we put it on the z-score. Anything below that would be below it, so at least, and then that would be higher, right? So then you would do the right. Because it wouldn't be any, I don't think it would be the left side. In my mind, it would be the right side should be highlighted. But I don't know.
Why would the right side be highlighted?
Because it's at least, so you want to go to at least the z-score. So, because all the stuff below it is below the z-score.
But if you shade to the right, you're just shading.
You're doing at least the z-score and more.
Yeah, you're doing and more.
But you're doing all less then, right?
Well, it's up to, so our z-score is 1.091, so it's going up to 1.091. So it's getting up to that number, at least that number. Whereas if you shaded to the right, that would be more than that number. That's how it's working in my mind, at least.
You're welcome to ask me too.
What do you think?
So I see where you're coming from. But is it Devin? Is that how you say your name?
Yeah, Devin.
Okay. Yeah, she's actually got it right. You would shade to the right because we're wondering if the question is asking when it says at least 35 hits, we want to know because I'm trying to think of how to explain this. So we want to, if you go back to the information, it says we want to determine the probability she will get more than 35 hits in her next 100 bats.
Okay.
But her average is 0.3. So we want to know when it says at least 35 hits, we want, that's our minimum. If we get lower than that, then we haven't met our criteria. So we want 35 or more. I don't know if that makes sense.
Okay.
Yeah,
I
you explained
guess
it much
that
better than I
makes-
could.
This is one reason I'm just like, so I'm an English major, heads up. I'm just like, I wish someone who is half English major, half math major would be in here because the way that things are worded are really confusing.
Yeah.
I'm just like,
I agree.
the better ways. Okay.
But if you look at what he was saying before, like the little information above question 10, it says that like we want to determine the probability that she will get more than 35 hits. And then I guess that's why it's saying what's the probability she'll get at least it and then more.
Okay.
But yeah, I agree.
You should
There are
say
some
at
of these
least
questions
and
are way
more.
too- Yeah, that's true. I agree. Every question should follow so that you understand the whole thing.
There's a saying in my class that I'm taking right now in English is don't make people think when it comes to understanding your setup.
That is true. That's a good point.
That's how you do a good setup. But well, what number did you get once you shaded it to the right?
0.138. That's after rounding.
138. Okay.
Yeah. All right, I'll read the next one. If the true proportion of people who support a political candidate is P equals 0.52, and if N equals 2,000 people are surveyed, 2,000 people are surveyed, we want to determine the probability that the results of the survey will suggest the candidate is losing the election, so getting less than 50% of the votes. What is the standard deviation of P hat?
I feel like I get these kind of answers on the exam and I think I get them wrong, since I don't know which questions I got wrong when I start getting 3 zeros before some numbers. And then I don't know what to put in.
I agree. I got the 0.011.
I'm still figuring it out.
Tell me what numbers you used, Devin.
I just used the P 0.52 and then the 2,000.
2.
And then just did the standard deviation of P hat.
Oh, I missed the standard deviation. I'm sorry. I didn't do the extra step. No wonder.
Oh, cutie.
So, how do you get P hat in this when you figured it out?
So I didn't even put P hat in there.
Okay, I think I'm looking at the
Because I
wrong
think-
equation that I wrote down.
Sorry, I think I.
What did you get?
It's 0.011. I don't know if it's correct, but that's what I got.
That's what I got too.
Okay, good.
Oh boy.
That's why I like multiple choice questions, because then you can, you know your answer's in there or not. You're not going crazy. Are you still working it out, Angie?
Yeah, sorry. Just give me another second.
No, take your time. Are we doing this right, Adam? This-
Oh, I think I forgot just to do. Let me see if that solves it.
It looks good to me so far. That's what I got too. So
Okay.
Did I receive?
What'd you say?
are you talking to me or?
I think Angie said something, but it went.
I lost sound again, but I'm back. Sorry.
Oh, okay.
0.011.
Yep. Did you get? Yay!
Yay!
Okay. What z-score would you use?
So 15. Yeah. What z-score would you use?
Okay.
wants cheese on a hamburger, I would recommend you grab a hamburger, put it on your plate.
I got 1.79.
Can you explain how you got that? I haven't.
Not sure whether I'm using the right numbers, but what I did was I used, no, I don't think I did that right actually.
Wait, what numbers did you use?
I did 0.52 minus 0.5 divided by the standard deviation that we got.
Okay, you got negative 1.79?
Yeah, that's what it would be, I think.
Yeah, that's what I just got when you, how did you know to use 0.5?
It says
Oh,
the
50%, I got it.
50%, yeah.
Yep, okay. Yeah, I got negative 0.1792.
Just a comment on that. If you got 1.79 instead of negative 1.79,
Mhm.
then that would mean that you switched p and p hat. The formula always puts p hat first, which in this case is 0.5. So
Oh, okay. So anytime it says a percentage, that will become the p-value, or the p-hat value?
I believe
Or not
so.
every time, I guess that's
think
like a very broad.
Yeah. Yeah, it's p hat. I don't know if this helps, but p hat is typically the value or the proportion that we are interested in comparing to whatever our true proportion is.
Okay.
So in the case of the baseball hits, our true proportion was 0.3, and then p hat was what we were interested in testing, which was the 0.35. We wanted to see how that stacked up against the true proportion. So in this case, our true proportion is 0.52. So we want to calculate the probability, and the candidate would lose the election if they had less than 50% of the votes. So that becomes what we're interested in testing against the true proportion. Does that make sense?
Yep, that makes perfect sense. Yeah.
Okay.
Angie, you got that? You feel good about it?
So it's not a negative or it is a negative? Sorry.
It is a negative.
It
Yeah,
is a negative? I'll have to
Yep.
think about that some more.
Yeah.
Okay.
So go to in the textbook, it's under section 3.3. In that
Okay.
formula, it shows that p hat. The formula is p hat minus p, and if you think about it, so p hat is the proportion that we're interested in testing. So if that value is higher than the true proportion, then you will end up with a positive number. If it's lower than the true proportion, you'll end up with a negative number. And that translates directly to a positive or negative z-score, respectively.
Okay.
So
That makes sense.
Yes.
so in this case, because the proportion that we're interested in testing, which was the 50% of the votes, because that's lower than our true proportion, right away, it takes a little bit of practice, but right away you'll know that you're going to end up with a negative z-score.
Yeah, that makes sense. Yeah.
Okay. And then I don't have anything fancy like that. I was just doing it on my phone calculator, and I'm just a little bit different. I got 1.818. So
818.
I don't know if that's a rounding thing. I didn't think I rounded.
So what numbers did you put in your equation?
The 0.52 minus 0.5, which I see is reversed.
It'd be the other way around, yeah. 0.5 minus 0.52.
And then divided by what? Did you divide it by 0.011, Angie? I don't know, 7.
Did we lose her again?
Yeah, I think so.
Gesundheit.
Thank you.
I'll try typing. Oh, are you there, Angie?
Again.
Oh, wow, that was crazy. She muted her mic and turned off her picture. I don't know. I don't know what happened.
That's funny. Okay.
Right.
So yeah, we'll come back and help her if we get her back. But you guys,
Okay.
it sounds like the two of you got that question right?
Yep, that made sense once you explained the P.
Okay, cool. And incidentally, another cool thing about that one is in this formula is identical to when we were calculating the z-score for a mean when we were doing quantitative data instead of categorical. The formula is the same, except before it was x bar minus mu over the standard deviation. Now it's p hat minus p over the standard deviation. And in both instances, what we've effectively done, when you divide the value of interest, when you take the value of interest and subtract the population mean or the true proportion, both this are the same in this case. When you subtract those and divide that number by your standard deviation, what you've effectively done is you've turned your value of interest into standard deviation units. And that's what a z-score is standard deviation units. So when we got that z-score of negative 1.79, what we've basically said is that 50% a proportion of 0.5 is 1.79 standard deviation units below the mean.
Oh, that makes sense.
That makes sense.
Yeah, that's crazy.
Yeah.
How it
So
all works together.
Yeah, it's for me it helps to put it in perspective, like why this is important, I guess. But
Yeah, that's true. Helps you actually be motivated to do it. Makes sense.
do we have Angie back yet? Oh, nope, maybe not.
Again.
All right, should we do the last one, or do you want to wait, or what do you think?
We just need to put it in the normality applet.
Oh, that's true.
Yeah, it's a pretty straightforward one.
Straightforward one. Negative 1.7. Point 0.037.
Yep.
Oh wait, hold on a second. Yeah.
We've lost another one.
Hello? It's Angie. Oh, you're okay.
Oh.
Yeah, I'll put you on speaker. We just finished the last one. So you got the negative 1.79, right?
What number was
That's for 15.
15? Sure that I have that right.
Oh no.
I lost her call on my phone. She's in Texas right now, on like a military base, so I think that's why
Right.
she's having such bad service. So I can help her work
Gotcha.
through this last bit. That's not a problem. So we don't all have to wait and hope that it'll work.
Cool.
But thank you so
Yeah,
much for your help.
Yeah, no worries. Yeah, you guys did awesome. I have one. comment. At least I think I do. I was taking little notes here as we were going. Oh, yes. For question, I don't know what question it was for you because mine is different. But it was like question 7 or 8 or something. It says if P equals 1 out of 4, what is the smallest n that satisfies the requirement?
Mm-hmm.
Do you understand why it's 40 and not the 13.3?
No, can you explain that to us? Or to me at least, I don't understand it.
So when you plug in that P equals 1 out of 4, you have to plug in that proportion into both the n times P is greater than or equal to 10, and the n times 1 minus P is greater than or equal to 10 formulas.
Oh, okay.
And when you plug it into both of those formulas, you want to use the largest of those two because, and this is, I've seen it, some people have a hard time grasping this because they think, what's the smallest n? And they go with the smallest of those two numbers. But we want the smallest n or population size that satisfies both of those. 40 satisfies both 40 and 13.3, but 13.3 does not satisfy 40. Does that make sense?
Yeah, that makes sense. Hey, Angie, I'll call you back in just a second, okay?
It's like the
I was-
needing a big enough population size for that graph to be normal sort of thing. You want
Or
the-
have it normal, yeah.
it needs to be big enough.
Yep.
Okay, so you have to pick the bigger one to actually satisfy it. Since the 13.7 didn't satisfy it, then the 40 does.
Yep. So yeah, don't let the wording of that confuse you. The smallest n is always the one that satisfies both requirements. So which will always be the largest one of the two when you put the proportion into both of those formulas.
Oh, that makes much more sense. I was like kind of confused, but I didn't really understand. So yeah, thank you. That helps. Yeah.
Cool. That was my only other comment. So I'll go ahead and sign off now. But,
I have a question for you.
oh yeah, absolutely.
Do you know for the tests if we'll be shown which questions we got wrong?
So you don't get shown right away. This is my understanding. You don't get shown right away, and iLearn doesn't show you. I wish I had the capability of going over them with students who are interested, but Brother Bennett Brother Bennett is your teacher, right? Yeah.
Yeah.
I TA for another group too, another teacher.
Cool.
But Brother Bennett has requested that if students want to know like what questions they missed, that they go to him directly, but he's more than willing to do that. So just shoot him an email, and if you're interested, and say I want to know what questions I missed, and he can go walk through those questions with you. So
That would be beautiful. I'll do that then.
cool. One other thing, actually, I'm not sure. I think I sent an email out about this, but I'm also available for one-on-one like tutoring if any of you need it. If that's the case, just shoot me an email and we can work that out.
Okay.
So I'm
Yeah, that
also
sounds
planning
great.
on doing a review session before the next exam. When is the next exam?
We just
We
had
just
this
had
past,
one, so.
yeah.
Yeah. I wish I had done one for the last one, but it didn't happen. But I'll try to work that out, and I'll send an email